How do airplanes fly? Airplanes are able to fly because of the physics involved. When an airplane flies, the air flows faster over the top of the wing than underneath it. This means that air is drawn up and over, resulting in lift, just like when you blow on a piece of paper. Everyday airplanes take to the skies and bring those who need their services across an entire country or around the world. How do they fly and what makes them function? Let's take a look at how airplanes work and what makes them fly. Brief history of flying. Now the Wright brothers are known as the inventors of the airplane, but they were hardly the first to fly. There are a number of cultures that have creation myths and speak to flight without any technological help. The Wright brothers were well familiar with George's work, and they knew that if they wanted to truly fly, they would need to create an airplane that used this technology. Their first successful attempts at flight were made in 1903 at Kitty Hawk, North Carolina. The airplane had a wingspan of 40 feet and it was propelled by a propeller that was turned by their internal combustion engine. Over the next few years, they would continue to test and redesign the aircraft, and today we know it as the Wright Flyer. After the Wright brothers provided that they could fly, many people around the world began to experiment with different shapes and sizes for aircraft. The Germans created a biplane that was called the Flying Pig, and it took flight for the first time in 1910. The Wright brothers went on to create a number of different models and even conducted flight training and aerial demonstrations, but it wasn't long before those who had been inspired by their success began to take these ideas and tried them out for themselves. By 1914, the first American aviator took flight and was certified as a pilot. How does an airplane fly? The first aircraft didn't actually fly that well, but if you put one of these early aircraft next to a real bird, the two would definitely look similar. Airplanes had taken on some of the characteristics of birds that is provided very useful in many ways. For example, the shape of aircraft allowed them to take off, and like the birds, that they become an integral part of transportation systems. Airplanes that we know and love today typically use a tail lift mechanism that uses air flowing over the rear of the aircraft. The tail lift is actually a winglet and gives lift to the aircraft by pulling air towards it. This creates lifts and enables the stabilizer or horizontal tail fin to work so that the entire craft can fly. How do airplanes take off? Airplanes lift off by using the Bernoulli principle to maintain the balance of forces. This is done by using angles. All airplanes, paper planes, and model planes, whether air powered or not, rely on this principle to fly. When fluid flows over a curved surface, it speeds up on one side and slows down on the other. The angle that an airplane starts its takeoff will be called its angle of attack. Ideally, it should have a 3-degree angle of attack. In order to take off correctly, the wings generate downward pressure, which will also provide lift so long as there are other factors contributing to this force, such as atmosphere resistance and engine thrusting forward. What forces keep a plane in the air? Like every other object on the earth, the airplanes move because of Newton's first law. There are four different forces that keep an airplane up in the air. Let's review what those forces are and how they play a part in keeping airplanes in the air. Lift. Number one, the first force that keeps planes aloft is lift. Lift is created by the movement of air over an aerofoil, and it works Much like a wing, the greater this difference between horizontal and vertical velocity, the more lift will be produced. To further complicate things, there are two different kinds of lift: angle of attack and induced angle. Angle of attack refers to the angle that the wing is tilted with respect to the oncoming air stream. Induced lift is created by large engines, and it is created when air moves through a spinning propeller. Number 2, drag. Drag is the force that resists motion of an object through the air. Drag on an airplane is the result of both lift and weight. Larger wings produce greater amounts of a drag, while more weight makes it harder to keep the plane in the air. Number 3, weight. Weight is the force that resists an object's movement through the air. It can be found in two ways: weight due to gravity or weight due to lift. Weight due to gravity will cause a downward force on the aircraft, making it harder for it to stay in fair flight. Weight due to lift will cause an upward force on the aircraft, which makes it easier for an airplane to stay in flight. Number 4, thrust. Thrust is the force that pushes and pulls an airplane against the direction of gravity. It is generated by a propeller, a jet engine, or any other propulsion device. One side of this force is the forward thrust, which pushes the airplane forward and down. The other side is called back thrust, which helps offset gravity and keeps aircraft in flight. How does an airplane make turns? The first step forwards flying is learning how to change direction. To leave or enter a turn, an aircraft must move in the opposite direction of the turn itself. The rate at which an airplane turns is also important. Fast turns will make it hard to other aircraft to attract them, and slow turns will make the flight harder to control. Rate of turn. It takes skill to maintain flight like this, where one should be able to keep triplet planes inside each other airspace without colliding. To do this, an aircraft must maintain a high rate of turn. Angle of attack. The first step towards flying is learning how to change direction. To leave or enter a turn, an aircraft must move in the opposite direction of the turn itself. The rate at which an airplane turns is also important. Fast turns will make it hard for other aircraft to track them, and slow turns will make the flight harder to control.